Isaac.
Yeah, Misa?
Hey, so I learned this new thing in class today. It's called a derivative, but I don't really know what it is. Do you think you can help me explain it more?
Yeah, sure. Well, you might not actually know this, but you learned about a derivative back in algebra, and it's the slope of a curve that translates to the rate of change when looking at real-life applications. Both the slope and the instantaneous rate of change are equivalent, and the function to find both of these at any point is called the derivative. When we're looking at curves instead of linear graphs, it gets difficult because the slope at every point is constantly changing. A way to find the slope is using the rise over run method, or the formula for slope, which is y2 minus y1 over x2 minus x1. And it can also be used to find the slope of a curved line, but only at approximation, and only if the 2 points are close enough. So, if we need to find an easier way to find the slope of a curve, there are many ways to do this, but today I'm just going to teach you how to find the slope of a polynomial function using product rule and quotient rule.
So you're saying I could use product rule to find a derivative?
Yeah.
So when exactly do I use the product rule?
Well, product rule, you usually do it when you see a multiplication sign when you're trying to find the derivative. And the first thing that should pop up in your head is product rule. An example, and the definition of this would be first times the derivative of the second plus the second times the derivative of the first. And it would look something like f of x times g of x, usually, or any other function. You get what I'm saying?
A little bit, but so what you showed here, you would need two functions for.
Yeah.
So can you show me an example if you had one function with multiplication in it?
Sure. Let's use 3x to the fifth times 12x cubed.
Okay.
Alright, so now, obviously we're going to use product rule. Do you know why?
Well, I see a multiplication symbol, so
Alright,
product, multiplication, kind of,
yeah,
hand.
you're getting the hang of it. Alright, so with product rule, in this situation you use 3x to the first, which would be 3x to the fifth, times the second, which would be 36x squared.
Wait, times the second? I thought it was the derivative of the second.
You're right. I mean, I can afford to mess up, but you can't. That's the thing. Alright, so the derivative of the second would be 12x cubed, which is 36x squared, plus the second, which is 12x cubed, times the derivative of the first, which would be 3x fifth, which equals 15x to the fourth. And at the bottom of the screen, that's how it should come out to 3x to the fifth times 36x squared plus 12x cubed times 15x to the fourth.
Okay, so wait, I'm a little confused. How do you get 36x squared? Isn't 12 times 2 24?
No, it would be 12 times 3, because you take
Oh, so you multiply the exponent before you minus it by 1.
Yep.
Okay, makes sense.
Alright.
So what happens if I don't have a function with multiplication in it? How about if I say I have a function with, say, division in it?
Well, then you'd use the quotient rule. And the quotient rule is just division. Dividing any two functions, and anytime you see a division sign, that's what you should use. And the definition would be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by denominator squared. And it would look like something like f of x over g of x, and it shows it at the bottom of the screen. Do you get what I'm talking about?
Yeah, I think I could use some practice on this one. It looks harder than the multiplication one.
Alright, so we'll use 6x squared over 2x cubed. Now, obviously we're using quotient rule because it's dividing, but the way that I explained it, do you think you could try this one?
Yeah.
Okay, so what would you do first?
So I would take the denominator first, right?
Yeah.
And times by the derivative of the numerator.
Yep.
And then I would add it to the...
Actually, you subtract it.
Okay, yeah, I minus it.
Yep.
So minus is for quotient, adding is for product.
Yep.
Okay. So I minus the numerator
Uh-huh.
and times it by the derivative of the denominator.
And
That's my answer.
you actually missed one really important step. You forgot to divide by the denominator squared.
Oh, yeah.
It's alright. You're just getting the hang of this. So, at the bottom, it should be what it looks like. 2x cubed times 12x minus 6x squared times 6x squared. All over 2x cubed squared. So do you get what I'm talking about now that you had some practice?
Yeah, I think so. So, quotient rule is the denominator times the derivative of the numerator
Yeah.
minus
Yes.
the numerator times the
Uh-huh.
derivative of the denominator.
Yep.
And we can't forget it's all divided by the denominator squared.
Exactly. Now what about product rule?
Product rule, which is simpler, is the first
Yeah.
times the derivative of the second
Uh-huh.
plus
Yeah.
the second times the derivative of the first.
Yeah. There you go.
Thank you, Isaac.
Yeah, no problem.
So what happens if I have multiplication in the numerator? Do I have to use product and quotient rule?
Yeah, you do, and that's a lot. It's a lot more difficult than what you know now, but knowing the gist of it, you should be able to get it. But I'm not going over that because ain't nobody got time for that.
Dang.
Yeah. So maybe some other time.